Hi children, good morning. Welcome back to the maths class. So, we have learned in the previous videos about the factors, multiples, definitions. We have learned how to write the factors, how to write the multiples. But how to find the prime factors for any numbers. So, that is today's concept, and let us see how many methods are there to find it out. How to find the prime factors. Okay. So, in common you understood how to find the factors, but there are methods which have to be followed to find out the prime factors. There are two methods to find these factors. One is factor tree method and the other one is prime factorization method. Prime factorization method. Yes, so most of you know about the factor tree. You are very much familiar in your schools and things with the factor tree method. So let us take some examples and understand how to write this factor tree. Suppose if any number is given, like suppose 12 is given, you need to write them. See, first and foremost thing what you should understand before writing the factor tree method is prime factors means, factor means to split the number. Okay, to segregate, that means to make it into smaller things. But how to make the big number into smaller things, using which numbers means it should only be used with the prime numbers. That is why this is called prime factorization or prime factors we tell, because here we are very much insisted that you should take the factors which are only prime. Okay, you cannot take different composite numbers here. So that is the reason why I have sent in my previous videos about the basics of this prime and composite. How to know the prime numbers, how to know the composite numbers and all. So that is all the basic for this, and it is linked up with this how to find. So 12. See, suppose if you take number 12. How to find the prime factors for this? First thing, you should take the factors in such a way that at least one of its factor is a prime number. That means, see, I cannot write 1 12s are. Okay, you should take another number. Suppose 2. Is 2 a prime number, children? Yes. So before writing this one, you just write it for a hint that write the prime numbers 2, 3, 5, 7 and 11. The first five prime numbers these are. So that you can understand. Okay, in 2 table, right, in 2 table I know it will go for 6 times. Yes or no? See, one is a prime number and the other one is a composite number. So, if it is a composite number, now prime number cannot be split. Why? Because it has only 2 factors. But composite number, you can split the composite number and see first of all how many times it will go again. Again, take one of it as a prime number and the other one as, if possible, prime number or a composite number. Split in such a way. So, 2 3s are 6. Now see how you will read this 12. How to write factors. That means how you will read the 12 is 2 times of, see I am circling the last ones which are not repeated, which are not segregated after. After that you have not segregated them. So they are all prime numbers. So 2 times of 3. Yes or no? So even though you segregate, you get only, see this one you will get 1 2s are, this one also 1 2s are and 1 3s are. Yes or no? Because they have only 2 factors and they will be getting only the factor. One is a factor and the other one is a 1. So you can write this 12 as 2 times of 3. Now see children, you can cross check your answer when by multiplying this. 2 times of 2 is how much? Yes, 4. 4 times of 3 is how much? Yes, 12. Did you get your answer back? It means that you have done right. You have found factors, only prime numbers. So you have found factors, the prime factors of 12 you have found using factor tree method. Okay, so did you understand the factor tree? How the tree starts to spread its branches. In such a way, we will spread the main number into different things, so that one is a prime number and the other one may be a prime or a composite number, so that this splitting continues until you get the prime numbers. Is that clear, children? So is that clear? Did you understand how to do the factor tree method? Yes. So this is the way how you do, and you should never put an is equal to here because we have written 12. So 12 can be expressed as the product of the prime. Prime factors means that only, children. Even when you find, see when we are finding this one, 2 times of 2 is 4 and 4 times of 3 is 12. Yes or no? Are these all prime numbers or composite numbers? Yes, they are all prime numbers. So our theme is not finding factors. We should find prime factors for the given number. Okay? Did you understand that? So in that prime factors we are having 2 methods, and one of the topic is completed, that is factor tree method is completed. So please practice this factor tree method with different numbers. Take different numbers like 18, 20, 24, your wish. Take them and just happily split them properly until you get the prime numbers. Your ending numbers should be the prime numbers. And once you end and you are not about to split, please round off it so that you may not get confused. Is that clear, children? Yes. Now prime factorization method. What do you mean by prime factorization method here? Prime factorization method means it is nothing but if a number is expressed as a product of its prime numbers. Same thing. That is only happening here. Yes or no? As a product. But this is a different method and that is a different method. Okay. So as a product of its prime numbers, then we tell it as a prime factorization method. See, suppose if you take 12 only, here when you are about to do, you should take, children, only, you have to take only the prime numbers. So which number you would like to take? 2. How many times it will go? 2 will go for 6 times. So 6, right? 6 here. That means this is the divisor, this is the quotient, and this is the dividend. Here no remainder, children, because we don't write remainder anywhere, because the reason is we are taking the numbers which are exactly divisible. So for everything 0 only, no? That is why we don't write remainder anywhere. So next, again continue the division with another number, once again either with 2 or 3. Okay? 2 will go for how many times, children? Yes, 3 times. Will it go anymore? Yes, it will go only in 3 table, children, but it will go only for 1 time. Please continue the prime factorization method until you get 1. Is that clear, children? And so, now you tell me 12 is expressed in terms of 2 times of 2 times of 3 times of 1. So when you multiply that, you will be getting back the same thing, that is 12. Did you understand? Yes. So as per the definition, we are writing, see the definition, according to the definition, see you can see prime factorization method means if a number is expressed as a product of its prime numbers, that is called prime factorization method. So did you get the definition apt with this sum, children? Yes, yes. Please write the prime numbers when you are about to do the prime factorization method. Okay. And one more thing, if as the number is very small, I have taken the initial prime numbers, and if the number is a little bit big, like suppose if there is a number called 224, okay, for such kind of numbers you should use your divisibility rules in order to know, because we have already learnt in the previous videos, no, about the divisibility rules. These are all linking topics, children. Okay, so first you will see the last number 4. That means what? It is divisible by 2. Yes or no? So you can start it, like you can divide. If you can divide here, you can divide. If not, you can just divide and write the quotient here. Yes or no? Next, so that like that slowly you can continue the prime factorization method. So if the number is small, there is no necessity, but if the number is big, you should apply the divisibility rules in order to know in which table it is divisible, because you should be know whether it is divisible by a prime number or not. You will check with 2, 3. Instead of dividing and checking, if you keep in mind all the divisibility rules, there is no necessity to check it. Okay, it is the last number is 4, so it is exactly divisible. I can directly divide and write the number. Yes or no? So divisibility rules are that much useful for us. Did you understand, children? Yes. So do practice this prime factorization more. In the next video, we'll meet with the big topics like LCM and HCF, which are really very confusion. So we will take both of them into different videos, like LCM into one and HCF into one. So till here, if you have any of the suggestions or if you have any of the doubts to be clarified, or you want me to express it once again, explain or express it once again, please send me in my comment section. Like, share and subscribe. Thank you, children.